Today I'm going to be configuring HSRP, which stands for the Hot Standby Router Protocol. It's a Cisco proprietary fault redundancy protocol. So if a router was to go down, or that router's interface goes down, or the router loses connectivity to an IP address, the backup or standby router would take over. There are two versions, version 1 and version 2. Version 1 has a maximum group number of 256. Version 2 has a maximum number of groups of 4096. Version 2 uses a different multicast address compared to version 1, and there are general improvements to that protocol. Both versions use UDP port number 1985. So I'm going to be doing this in GNS3, and this is our topology. We have R1 and R2. We have PC1 and PC2, and we have another router which represents the internet. So R1 is going to be the primary group for VLAN 100 and the backup for VLAN 200, and R2 is going to be the primary group for VLAN 200 and the backup for VLAN 100. So yeah, at the moment I have configured the interfaces, so there's going to be sub interfaces on R1 and R2 for VLAN 100 and 200. Both these routers have got a BGP connection going to this www router, and if we have a look, and I've got a free loopback interfaces configured here, and these are the IP addresses used to connect to our network. So if we have a look at BGP, so all I've done is configure the neighbors and advertise the loopbacks to our devices here. If we have a look at R1, we can see that we see the BGP routes there. So if we have a look at the inside interfaces, so all I've done is configure these IP addresses here. And that is it. On PC1, which is just another router, I have configured a static route that's going to the virtual IP of the HSRP group for VLAN 100, and then on R2 it will be going to the group for VLAN 200. Okay, so I'll start off on R1. So we'll do this interface first for VLAN 100. So it's quite straightforward. So standby 100. So the 100 is just a group number. So we could do authentication for this. Just because it's a lab, I'll do it. I'll do the authentication in clear text. Next, we can do the IP address, which is going to be the virtual IP. So this will be the default gateway for our hosts. So this will be 192.168.100.1. We can give it a name. So I will call this VLAN 100-HSRP. We need to set the preempt. So this will mean that this router will always try to be active. It'd be easier just to show you now. And then we can set the priority. The default priority is 100. So let's set this a little bit higher than the default. So we'll call this 120 as an example. The timers we can leave be. We can track. We can track an interface, a physical interface. So if the outside interface was to go down, loses connectivity to the internet in our example, then it will switch over then to the standby. So we will track our outside interface and then our decrement value. So we've set it to 120. The backup router will be 100, so it needs to be less than 100. So I'll set it to 30. And I think that's about it. So do show IP. And let's just have a look at the config. Do show run. Okay. Now we will configure R2 on VLAN 100. So this will be the backup. It's relatively straightforward. I mean, there's less config than the primary. So standby 100, authentication Cisco 123. The IP is going to be 192.168.100.1. The name, I'll just grab it from here. The preempt, and we don't need to set a tracker on this one. Okay, so let us just review that, and there we see it's gone to standby. We can do a show standby brief. So this tells us our group, our priority. It's in a standby state, and it's telling us the standby is local. If we do the same on the primary, so this is telling us this is active here. So if we go to our PC on VLAN 100, we should be able to ping one of those IP addresses, which we can't. I think I know why. It's because we haven't configured NAT. Okay, so let's just configure NAT. So we'll set IP NAT outside, and then we will do .100 here, IP NAT inside. Let's configure an access list. IP access list, we'll do a standard. We'll call this VLAN 100 NAT. Permit 192.168.100.0 and the wildcard, and IP NAT inside source list. Where's our list name? Here we go. Interface FA0/that, and then overload. Let's try that again. And we have a success this time. We have a look at our trace route. We can see that it is going via 100.11, which is this interface here. Okay. So what if we lose this interface? What if it goes down? So let's just have a look. We'll just shut it down. Okay, so yeah, we see this going down, active to speak here. And then it's gone from standby to active. And then if we go back to PC1, do a trace, give it a second. I didn't configure NAT on R2, did I? And I am just going to steal the config from here. Let's try that again. Okay, there we go. So it's going to 100.22. 100.22. Okay. So we will configure R2 to be the primary for VLAN 200. So standby 200, authentication, text, Cisco 123. The IP for this will be 192.168.200.1. The name will be, I want to keep it roughly the same. VLAN 200, VLAN 200-HSRP. Preempt. And then the priority is going to be 120. And then we'll do the same here. So this would be 200 track FA0/0, and then we will decrement the value by 30. Okay, so let's just re-enable this interface. And then, yeah, there we go. It goes from standby to active, and then that is back up. And then, give that a second. There we go. It's, yeah, it's getting to its destination and it's routing the right way. Okay. So that is done for R2 for VLAN 200. Let us go into VLANs, this interface here, and then standby 200, authentication, text, Cisco 123. The IP is 192.168.200.1. The name is this. Okay. Yeah, so I'm gonna have to do that again on this. Do show run. Okay, so yeah, we'll just copy some of this. 200-NAT permit 192.168.200.0. That, and that. And then let's copy this directly to R2. Okay, so let us do a trace route from our PC2, which is on VLAN 200. Will it work? It's getting that far. I missed something here. All looks okay. So that is okay. IP NAT there. IP NAT inside. Let's try that again. Yep, there we go. I was missing the IP NAT inside. All right, so that is configured. So we go to R2 and let us shut down the outside interface. Did I not do that here either? I didn't do that here. Yep, there we go. It's missing those NAT statements. Okay, so yeah, that is being redundant now. But this is only so if a interface was to go down, then then that will cause the failover. But that may not be the best option um, for us. So even though something else might cause a failover. So let's say if we lose connectivity to an IP address on the internet, then that could also trigger a failover. So on R1, I'm going to set a SLA. So this router is going to be pinging an IP address on the internet, and if it loses pings to that IP address, then that will trigger a failover. Then, so this is done via the IP SLA. So IP SLA, and then we'll just give this a number. And we have to tell it what we want to ping, or in this case, the path echo. And then we'll just give it an IP. So we'll say that there, all the ones there. We could also set a timeout as well. So I'm going to set a timeout of, I don't know, this is in milliseconds. So we'll say 1000. Okay, so we'll set 5,000, and then we can set a frequency of 5. And then we need to say when to schedule this SLA as well. So we could do an IP SLA schedule. The number we want to give it, we'll give it 100, but this doesn't tie into or does it? I'm not too sure whether this ties into the SLA that we just created, but we'll give it 100. And we'll say life forever, start now. Okay, and then we'll go back into our interface here. And then we can simply say standby 100 track 100 IP standby. No, sorry, I need to be in global first. Track 100 SLA IP SLA 100, and we can ignore those. We can also do a do show IP SLA statistics, and this tells us how many successes and how many failures we have to the IP address that we configured. So 14, 15. So yeah, that is all okay. Then we'll go back into our group on VLAN 100. And then we'll say standby 100 track 100 decrement 30. I think that'll be okay. So this is tracking the physical interface, and then this is going to be tracking the reachability to 1.1.1.1. So if I was to go over to the internet, and I just shut this down, we should see a failover. There we go. So yeah, that is so basically saying the reachability to that IP address has gone down, and then this device here has gone from active to speak, and then speak to standby. Go over to R2. We see that that is now active. Okay, so let's do a trace route. Why is that not working? That should be working. Scan and unreachable. So we get going to 200. We're not getting any BGP from here. Did I not enable the interface? There we go. Yeah, okay. So yeah, I didn't re-enable the interface. Try that again. Yeah, that's working. And that is taken, yeah, R2 through to the internet. So yeah, let's just re-enable that interface, and then everything should go back to normal. Yep. And there we have it. So I'll probably do a video on VRRP, which is the industry standard on the on this type of redundancy protocol. But for now, I think that is it. And yeah, thank you for watching.